I had a last idea for what we could do with the random walks. So let's take a look at that in this video. So first let's get our file open here. So what we have now is self-avoiding random walks like this, and forgotten what the commands are, so let me do it like this. Sorry, what the hotkeys are. So Z is zoom in and X is zoom out. So we have here some random self-avoiding random walks, which you can see different colors. The red will never cross itself. Same for the orange, same for the other colors. But I thought what would be fun was, what if we make them avoid each other as well? And to do that, we're going to change this one a little bit. So what do we do here? We create a point set of points, and then we check if we have visited that before. And basically, what we need to do is make this kind of a global variable that's shared between different calls of the function. So I'll do this, and then we shouldn't free it every time. But now let's try to run it, and that didn't. Right, because the number of steps is not declared here. So let's see where it's actually. It's given as an input here. So let's define a constant. And what did we have it as before? We had number of steps 20,000. So let's just do that. Let's remove it as an input here so we don't confuse ourselves. And I think that is all right. Let's try to run it now. So it still didn't compile because I forgot to change this thing. And initializer element is not constant. Okay, so we have to declare this here and set it to null, I guess, and then inside main we can do this. And what was it called? It was just called visited points. And let's try to run it. Okay, so now we have here some random walks that should never intersect. It seems that they're somehow right, so they are allowed to start at the same point. So also I don't want that. Let's define some other parameters. So here the start x and start y is kind of like given, but I want to generate those. And they also floats, which was kind of wrong. Okay, so I want to get start x as a random integer between minimum and maximum. And we can okay, I don't want that. Let's do, we probably don't need to cast it because it's already an integer. So yeah, something like this. And let's actually rename it to not random, but rand. Okay. So I think it's a good starting point to generate these points to be some random pixel. And then what we're gonna do is we're gonna say while this has been seen before, then we'll generate a new point. But actually also let's say max tries is probably 100, and let's not call it, let's just call it tries. Well, tries is less than max tries, and it's already visited. Then we'll do this, and then we'll say if we actually ended up using all our tries, or maybe there's a better thing we can do. We can say if it's actually for whatever reason an element, then we're just gonna say that the count is 0, and we will return points. Okay. So if we get here it's not a member, then we insert it, and then we keep going as usual. Let's try to run that. So it's complaining, it keeps complaining about time, so I think we can include that like this. Okay, so now that is declared, and then we have some calls to random walk here. Shouldn't have these parameters, and then great. So what's probably happening? No, it's not. Let's write successfully generate start point. Then run that. It's not showing anything, but we generated a starting point, and then let's go here and let's write, let's log what the count is. So it generates some points, but they are not shown. Why are they not shown? Number of runs, counts. We write into that. Let's just check, just a sanity check. That is correct. Go here. And what is number of runs? It's 5, so fine. What happens if we zoom in? Nothing happens. We can actually draw text, and I think let's draw it at 1010, and yeah, let's try that. That didn't work. Why didn't that work? let me have a look at the examples here, because let me do it another way. Let me do it like, not here, examples, and then we can grep for text format. Okay, so you do it in a slightly different way than I thought. Let's actually go here and let's say draw text. That's not the one, not the one, this one. Okay, so you give the text first, and then you give the, let's copy this one actually. It's a bit easier to work with. Then you give the position, say 1010, the font size and the color. So this should be it. And now we can see that the, oh, there they are. Okay, I guess I know what the problem is. We're assuming that the middle of the screen is 0. So actually I want to say divided by 2. Divided by 2. No, still a little bit off. But you can see we're generating some independent walks at least. And the step size is 3. What if we start at 1? Yeah, okay, this makes a lot more sense. Now, but why are they, they're kind of boring. We need some kind of way to recenter the screen. So let's say if is key down, actually it should be is key released. Maybe T, and also dx is 0, dy is 0. Now we can do this, we can press T and it kind of like snaps back, which is nice. So, so as an example, why is it so slow? Let's see what happened with this guy. Yeah, it just ended up here. So these self-avoiding random walks, they tend to be quite small, I guess. So let's try something. Let's just try to make a bunch of them. So number of runs, 500. But we'll need to say number of colors is 5. Yes, number of runs, blah, 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 number of runs. And here, background color. Now this guy. Should be mod number of colors. So we don't go off the end of the array. Let's see what happens. Something is happening for sure. It's very, very slow to zoom now and move. maybe now that we're making so many, it makes sense, especially since they're all so small, it makes sense to kind of clean up some of the unused space. So what's happening right now is we're generating 20,000, an array of 20,000 points, which is a lot of memory, but we're usually not using all of that. So down here, let's do something like this. Call it new points, and it's not gonna allocate 20,000. It's just gonna allocate however many we found, and then for count, we are gonna say this guy is the old guy. Then we can free the points and we can return the new points. So it's a little bit more memory efficient. I don't know if this will actually solve this problem. No, it doesn't, because we still have to iterate a bunch of times. Let's now this is the text section for whatever reason. So let's say iteration count is number of runs. Well, let's say 0, and then let's say exactly, and then we draw that text. Can I do that? Yes, it can. So each frame we are iterating 40,000 times, which doesn't seem like that much, but I guess it is that much. But maybe we don't worry about that right now. Let's try to not draw just for fun. That actually helped a lot. So the circles were causing a big issue, big slowdown. That's interesting. I wonder why there's like points out here. That's probably not right. But anyway, can we just like crank it up, generate 5,000 runs? It doesn't, like you kind of have to zoom in before it starts looking interesting, I think. Because this view is kind of like very, very messy, but this looks a bit interesting. Let's take a screenshot. This might be the thumbnail. Actually, that's a bit annoying. So let's have a Boolean that is like drawing info, which is true by default. Do we have Booleans? Yes, we do. And then we'll say here if drawing info, and this stuff should not be calculated per frame. It should be calculated here. Okay, so if we're drawing info, we will do this, and let's make another hotkey here. If key I is released, then we won't draw the info. So we'll do like this. Zoom in a bit so it looks more interesting. Turn off the info, and then we do a screenshot. Okay, nice. Let's do a final thing, which is where is this R thing defined? Okay, it's here. So let's add 2 more, and we will say it's inclusive. Yes, it's inclusive. So we'll say if it's 4 or 5, we will go right. So you see it's quite biased now. 3 times more often it will go right than the other direction. So let's see. Now we get this really funky texture. Kind of want to screenshot that as well. We can try something else. We can also bias it down here to go up, which of course looks like this. Let's change the colors a bit. These colors we might as well define here. Okay, then we also need to define these guys here. Does that even compile? Does not compile. We have to turn these into consts. That really doesn't. Maybe this one's const. Okay, so that worked. What is it printing? It's printing a bunch of counts, so that shouldn't be the case. Okay, so here we have our colors. Which ones are good? The green, let's get rid of the green. And let's make a bunch of reds, maybe. And 2 blues. Actually, I didn't need to do that. This. Keep this color selection. So, red 2. Okay, so this red, maybe it's just less bright. This red, let's give it some more green. And this blue, let's give it some more red. Okay. Not sure it's better. I mean, you would probably, if you want to make it look really good, you would have to spend some time thinking about color theory. What is that orange thing? Maybe it's this guy? Because the orange is really, yeah. No, that's not it. Is it this one? Yeah, I think so. So that orange is really bad. Let's try that's to purple. That's what if we just make it red, honestly? Like that. So it looks horrible out from afar. Here it's slightly more interesting. What about red 2? That one's a little bit more muted. Red 3. That one's quite purple. Blue. You could use these kind of pictures as like a phone background or something. But let's, oops, we need to go here and say 5. Purple still is not good. What if we make it something like this. It would be nice to like do with the mouse, highlight some area that you want to zoom into, but that's not something I want to implement right now. Okay, I think that's gonna do it for this video. But I will see you in the next one.